Hello, ladies and gentlemen. Mr. Hescox, your physical science teacher, back with you again. We're in Chapter 4, Section 2. This is on thermal energy and heat. But first, we got to talk about what is thermal energy. Thermal energy is the total, all of the particles, and all of their kinetic energy and how fast they are moving. The faster they're moving, the more kinetic energy, the more thermal energy. This will go along with this section, heat and temperature. And we'll talk a little about calories and specific heat and things like that. We'll read 110 to 114, and the review will be in the classroom. Energy flows from warmer objects to cooler objects. Heat is the flow. Heat is caused by difference in temperature. It always goes from hot to cold, hot to cold. Heat describes the speed at which those particles are moving because the faster particles bump into the slower particles, and they cause the slower particles to move faster while the faster particles slow down because they have given some of their energy to those slower particles. Heat and temperature. Heat is still that flow. Temperature is the average kinetic energy. Now we can use temperature to gauge heat and flow. With heat and thermal energy. Thermal energy is passed from the particles of one substance to another when those particles collide. It's all about the collisions. We talked about the collision theory. The faster the particles are moving, the more heat speed up the particles that they hit. So the faster you hit a pool ball, the faster it collides into the others. Thermal energy is changed when that one particle impacts energy to the other. A calorie is the amount of energy needed to raise 1 gram of water 1 degree Celsius. Food doesn't use the right definition of calorie. Calorie that they use in food is actually a kilocalorie, which is 1,000 grams, or 1,000 calories. A joule was started by the scientist Joule, who actually was a famous cannon maker. And 1 joule is 1 calorie, is 4.18 joules. We have the British thermal unit, except for we aren't Britain. But if you would buy a thermostat, or if you want to buy a heating system, or you buy a grill, they will measure it in BTUs, which is what the English used to use for heat. Some types of materials change temperature very, very easily, like the metal in a spoon. You ever grab a hold of a spoon that's been in a pot, it gets very hot, and you can burn your hand. If I have 2 beakers side by side, and there's water in my beakers, and this beaker is 30 degrees Celsius, and this beaker is 10 degrees Celsius, and I somehow connect them, maybe with a metal bar. So now the heat can flow through my metal bar as one particle hits and bounces into the next one, speeds that one up, speeds that one up. Eventually, it can travel all the way into this container. Now, some of this heat could be lost because the bar gets hot. But eventually, those beakers that are beside each other will hit a temperature that's the same for maybe not exactly around 20, but it'll be somewhere lower because that heat travels through. And eventually you'll hit this equilibrium where the heat in both sides will equal out. So when we're talking about water, we use specific heat of 4.18 or we use a calorie. Specific heat sounds a lot like a calorie, except for a calorie is the amount of energy needed to raise 1 gram of water. That key word there is water. When you hear the water, it's calorie. Now, specific heat is the amount of energy needed to raise 1 gram of any substance, wood, gold, iron. Like iron is 0.45. It has a very low specific heat. That's why if you have a very low specific heat, it tends to heat up very quickly and transfer the heat very quickly. Copper has a low specific heat. Water, styrofoam, things like that are insulators because they have a high specific heat. It takes a lot of energy for them to change temperature. Objects and heat. So the more mass an object has, generally speaking, it has more thermal energy, even though it may not be hotter. Like the ocean has an enormous amount of thermal energy, even though it's not as hot as a boiling pot of water. That because there are so many more particles traveling at a certain speed. That mass has a very big part. So lakes. I used to live by the ocean. I lived right across the bay on the eastern side of Maryland. The Chesapeake Bay is a large body of water. It doesn't get real warm. I mean, it's warm in the summertime to swim in, but it doesn't get like boiling temperatures. But it's enough thermal energy that when storms from the western side of Maryland hit it in the wintertime, the snow usually melts and it would fall as rain on the eastern seaboard. Here's an example. A boiling pot of water has less kinetic energy than a giant hot bathtub. Even though the pot of water might be way hotter in temperature, because the bathtub has so much more mass, it has more energy in it. Well, that takes us to the end of that section. And if you have any questions, come find me. Make sure that you're getting your work done, and until next time, be good, be safe.